Hey everyone, welcome back to the channel with today's LeetCode DCC question. Minimum length of a string after deleting similar ends. This question has been asked in previous interviews of Goldman Sachs and Bloomberg as well. Let's look at the problem statement. Given a string S consisting only of characters A, B, and C, you are asked to apply the following algorithm on the string any number of times and return the minimum length of string after performing the above operation any number of times. That means they have given an algorithm which includes condition 1, condition 2, condition 3, condition 4, and condition 5. This is an algorithm. So we can apply this algorithm as many number of times, and at the end we have to return the smallest string which are left, the length of that string. And one more thing, they have given that the string length consists of only A, B, and C character. Now let's look at the condition one by one. Pick a non-empty prefix from the string S where all the characters in the prefix are equal. That means given a string S, we have to pick some non-empty prefix and some non-empty suffix. And how the prefix and suffix should be? Prefix should not be empty, and all the characters in the prefix are equal and all the characters in the suffix are equal. So if we take this example, if we consider this string as a prefix or suffix, is it valid? Yes, it is valid because in this is not empty and it contains only single character, means similar characters. All characters are A. If we consider this string as a prefix or suffix, this is invalid because it contains A as well as B. So it contains more than one characters. Now, if we see this string double B double A, again this is not valid because again it contains two distinct characters. Similarly, this is also invalid, but yeah, this is valid because it contains all C's. So we can consider this type of string as a prefix or suffix. If we consider this string, this is also invalid because they have mentioned that prefix and suffix cannot be empty. And since this string is empty, we cannot consider this as a prefix or suffix. Let's see this string. This string can also be considered as a prefix or suffix because it contains only one character. They haven't mentioned or restrict the on the length of the prefix or suffix. So this is also valid. Now let's look at point 3. The prefix and suffix should not intersect at any index. Suppose this is the given string and we consider this blue border as a prefix part and this red border as a suffix part. We can see these three characters A, and A are common in both the prefix and suffix. So this is invalid. The character should not intersect with prefix and suffix. If we see the ending index of prefixes here and ending starting index of suffix is here, and we can see it is intersecting. So this is invalid. Now let's see this example. Suppose this is the string blue part is a prefix, red part is a suffix. So we can see this both prefix and suffix are not overlapping. Hence, this can be the possibility of prefix and suffix. Let's see this example. So in this example, we can see blue border is a prefix. If we consider and red border as suffix, we can see again there is no overlapping of the characters. Hence, this can also be a part of prefix and suffix. Now let's look at the condition for the character from the prefix and suffix must be the same. Now suppose we have considered this part as a prefix and this part as a suffix, and they are not overlapping, right? They are not overlapping. From condition 3, they are not overlapping, and from condition 1 and condition 2, we are sure that either this prefix contains all say or all B's or all C's. If prefix contains all A's, then the suffix chosen must contains all A's. And if prefix chosen is all B's, contains all B's, then the suffix chosen must be all B's. There cannot be a case like prefix contains A's and suffix contains b's. This is wrong. That what point condition 4 is saying. And if all these four conditions are satisfied, condition 1, condition 2, condition 3, condition 4, then we can delete this both prefix and suffix. So after deleting, we will get the smallest string from the original string. So we will apply this algorithm as many number of times it is possible, and at the end we have to return the minimum length of the string. So from the above we can see these are the points. So point 1 says prefix is not empty and contains either all A or B or C. Similarly, point 2 says suffix is not empty and contains either all A, all B or C. And point 3 says end index of prefix should be less than the start index of suffix. That is, there should not be any overlapping, no overlapping, right? No overlap. Now in point 4, in both prefix and suffix, character should be either all A, all B, all C. That means if we choose prefix and suffix, both must contain similar type of character, either all A, then suffix either all B or C. Let's suppose we have a string like A, B, C. Can we choose any suffix or can we choose any prefix or suffix that satisfies all the conditions? If we see the first character A and the last character C, if we consider this part as a prefix, it contains A, and if we consider this part as a suffix, it contains C. That means there is a difference in the character, so we cannot choose this as a prefix and suffix, and we cannot proceed further also. So in that case, we can say if in the beginning only the first character and the last character is same, is different, we cannot proceed. So if we take this example, the example is C, A, B, A, A, B, A, and C. Suppose we are here. Suppose I start choosing the prefix. Then prefix must contain C. And if prefix contains C, then suffix should also contain C. Let's see whether suffix have a C. Yes, suffix also have a C. So we can choose that means we have few characters that can be deleted, right? So if C is there, if we consider only one character from prefix and one character from suffix, and since they are not overlapping, that means there is a few character that can be deleted. Let's see whether we can increase the length of the prefix or not. So if we see the second character, it's A, it is different from C. That means we cannot include A as a prefix part. So at the first step, our prefix is only C. Now let's see. Now we are here. Now let's see for suffix whether we can increase the length of the suffix or not. If we see C, the second last character is A. That means we cannot include A as a part of a suffix because both the characters are different. Hence, we in the suffix part also we will have only C. Now, since both the characters are same, and both are not overlapping, that means we can delete. So after deleting, so the string left will be A, B, A, 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 B, and A. Now again we see we are ahead. So prefix pointer is here and suffix pointer is here. Now first character is A. Let me see whether we can proceed or not. So if the last character is also A, then only we can proceed. That means the suffix part contains A. Yes, it contains. So we can, that means we have at least few character which can be deleted since they are not overlapping. Now we will see whether we can increase the length of the prefix or not. Let's see. So second character is B. That means it is different from the first character. We cannot proceed. So the prefix will only contain A. Now let's see whether we can increase the length of the suffix or not. Since suffix contains A, let's see. The second last character is B, and it is not equal to the first last character. That means we cannot include B as a part of a suffix. So now suffix will be A. So we can delete both prefix and suffix as both contains similar characters A, and they are not overlapping. So we can delete this and this. Now let's see. The remaining string is B, A, A, B. Now again, let's see. This is the prefix and this is the suffix. Now let's see the prefix part. The first character of prefix is B. Let's see whether the suffix contains the B or not. So we can see the last character of suffix is B. That means we have at least one character which can be deleted, right? So let's see whether we can increase the length of the suffix or not, prefix or not. So if we see after B, there is A. That means it is different from the first character. So we cannot include A in the prefix part. So prefix will contain only B. Now let's see whether we can increase the length of the suffix or not. So before B, it is A. That means A is different from B and hence A cannot be included as a part of a suffix. So suffix will only contain B. So we will delete both B. Now we are left with only A. So our prefix pointer is here and suffix pointer is here. Now let's see. The first character is A. Now let's see whether suffix can contain any of the A. So we can see the suffix also contains A. So we included this. Now let's see whether we can increase the length of the string or not, prefix or not. If we see the next character is also A, but it has been used by the suffix. So we cannot include this A as a part of prefix. So, and similarly for the case of suffix. So if we see before A, there is another A, but this A has already been taken by the prefix. So we cannot overlap, hence prefix contains only A, prefix contains only A, and suffix also contains only A. Now we can see both contains A and both are not overlapping. Hence, we can delete this A, this A. So after deleting, we are not left with any of the strings. So string is empty. So the minimum length of the string which we can achieve after applying the algorithm is 0. So we can see how many times we have applied the algorithm. 1 time, 2 time, 3 time, and 4 times. So applying this algorithm 4 times, we reduce the string from 1, 2, 3, 4, 5, 6 from 8 to 0. So we can see the output of this example was also 0. Now let's see next example, this example. If we see string S is C and A. If now prefix pointer is at the start and the suffix pointer is at the end. If we see the first character of prefix is C. So can we now let's see whether suffix contains C or not. So if we see the first character of suffix is A, that means it is not equal to C. So we cannot proceed as suffix prefix contains C and suffix contains A. So both are not equal, hence we cannot delete any of the characters. So hence at the end, we cannot apply this algorithm any number of times. So the output of the final result will be 2. Now let's see example 3. If we take this example, double A, double, so string is double A, B, double C A, double B A, double C A, double B A. So now our prefix pointer is pointing to the first character and the suffix pointer is pointing to the last character, right? Now we can see whether first character matches with the last character or not. Yes, it matches. That means there is a few character which can be deleted by applying this algorithm since they are not overlapping. So now let's see whether we can extend our prefix part or not. So we can see the next character after A is also A. That means we can include this A. Now also the characters remain same. So now we will see whether we can include B or not. So since B is not equal to A, we cannot include B. So our prefix remains till 2 characters. So now our prefix part is only A and A. Now let's see suffix. So before A, we can see the character is B, which is not equal to A. Hence, we cannot increase the length of the suffix. So it will only be restricted to length 1. Hence, now suffix is A. So we can see the distinct character in prefix is A and distinct character in suffix is also A. Hence, we can delete both the prefix and suffix. So after deleting, so we have applied this algorithm 1 time. So after deleting, we are left with B, C, C, A and B, right? Now let's see. Our prefix pointer is pointing at this B and suffix pointer is pointing at this B. Now let's see whether first character matches with the last character or not. Yes, it matches. That means there is a few character which can be deleted. Now let's see whether it's overlapping or not. So we can see this is not overlapping. Now let's see whether we can extend the prefix part or not. If we can see the next character is C, which is not equal to B, hence we cannot extend the length of the prefix. So our prefix will be only B. Now let's see suffix. We can see the second last character of the string is B, and which is equal to the last character. Hence we can extend the suffix till here. Now let's see whether the next character of B is similar or not. So the next character is A. So which is not equal to B. Hence we cannot include A as a suffix part. So now the suffix part will restricted by BB. So we can see both prefix and suffix contain same character, that is B. Hence we can delete both the string and as they are not overlapping, we can delete. So after deleting, we are left with C, C and A. Now let's see. So our pointer is pointing at C and last suffix pointer is pointing at A. Now let's see whether the first character matches with the last character or not. So we can see C is not equal to A. Hence we cannot create a prefix which contains similar character as suffix. As we can see, if we increase our length also of suffix, it will at least contains A, and if we increase the length of a prefix, it will at least contain C, and which is not equal, and the distinct character will not match, right? So in this case, we cannot proceed. So our final length of the string will be C, C, and A. Hence, the length of the string will be 3. So we have applied this algorithm 2 times, and we are able to reduce the length of the string to 3. We can see the output was also 3. Now let's take one more example. Suppose we have only A as a string. Initially, our prefix pointer will point to this A and suffix pointer will also point to this A. Now, if we will check whether prefix and suffix are matching or not, yes, it is matching. Prefix is A and suffix is also A. Now we will see whether it is overlapping or not. So we can see this is index 0 and it is being shared by both prefix and suffix. Hence, we cannot satisfy the condition 3. So we cannot proceed. So in this case also, the length of the minimum string will be A. That is 1. So I hope the problem statement is clear. So if we talk about the time complexity, so we can see we are incrementing our prefix pointer from 0 to till length n and suffix pointer from length n to 0. So at most we are running the loop by O(n) times. Hence the time complexity of this will be big O of n. And if we talk about space complexity, since we are not using any of the space, we are just checking and incrementing the pointer. We are doing simple mathematical operations. So space complexity will be big O of 1. I hope the solution is clear. Let's try to code. So in this, first we will find the length of the string. Now we will keep a prefix pointer and a suffix pointer. Suffix pointer will point to the last index, and we will keep the answer as the original length of the string. If we will able to reduce the length, then we will update the answer. Now, since the prefix and suffix should not overlap, so I will write till prefix pointer is less than suffix pointer, we can run the algorithm. Now, first condition is we have to check whether the first character matches or not. If S of SP is equal to string of first prefix pointer is equal to a string of suffix pointer. Okay, the string is same. So let's make it str. So suffix pointer is, if this is the case, that means we have at least one character which is matching. So if this is the else, if it is not matching, then we will return the answer. That means we cannot choose any of the prefix and suffix which follows all the four conditions. Now in this also we can see whether we can increase the length of the prefix chosen or the length of the suffix chosen. So first we will run a while loop. So in this we can see, so we will increment the p pointer and decrement the suffix pointer. Now we will see while prefix is less than suffix and string of prefix current pointer is equal to string of p minus 1. That means the previous character is matching with the current character. In that case, we can increase the current pointer. So we will run this while loop till the character matches with the first character. And same we will do for the suffix part. If this is the case, we will decrement the pointer. So when it is done, we can update our answer with the current string length. So current string length will be s minus p plus 1. So this is the current length. So once we are done, and if there is no case where we are not able to choose any prefix or suffix, so we will not fall into these conditions. So at the end also, we will return the final answer. Now let's try to run the test cases. So we can see our sample test case has been accepted. Let's try to submit the solution. So our solution has been accepted. Hope the problem statement is clear and as well as the solution. If you have any questions, mention in the comments below. See you in the next video. Thank you.